Today we're going to add and subtract numbers written in scientific notation. So you know what's coming up in the expectations. We're first going to take the numbers written in scientific notation and rewrite them in standard form. We're then going to add or subtract to combine/simplify the numbers, and then write the final answer in scientific notation. The nice thing about this approach is it works 100% of the time, as long as your rewrite into and out of standard form is good. Looking at our first example, we have 2.3 times 10 to the third plus 6.9 times 10 to the third. We'll go ahead and expand these. 2.3 multiplied by 1,000 gets you 2,300. And if we do the same with our 6.9 times 10 to the third power, we also get 6,900. And so if we add these together, we get 9,200. And if we look at writing that from standard form to scientific notation, we want the decimal between the 9 and the 2 for that number between 1 and 10. It's currently behind the 0, so we would move it 3 times, which leaves us with 9.2 times 10 to the third power. Stays positive as we have a big number. Now looking at small numbers, we have 5.2 times 10 to the negative third minus 2.58 times 10 to the negative third. If we look to rewrite 5.2 times 10 to the negative third in standard form, we look to move the decimal left 3 times to get that very small number. So that's 0.0052. Doing the same for 2.58 times 10 to the third. We have moving the decimal 3 times to the left to get that small number, 0.00258. And if we go ahead and subtract, we have numbers there to hold the place. You could use your calculator at this point, go by hand. We're left with 0.00262. We do have a decimal here, but we want it to be between the 2 and 6 to get that into scientific notation. And so we would have to move the decimal 1, 2, 3 times. So that would be 2.62 times 10 to the negative third power. It's negative because we do have a very small number here. On this example, we have different sized exponents, which will change the overall size of the number, but not our process to combining these numbers. So we have 4.81 times 10 to the third power plus 7.913 times 10 to the fifth power. We'll go ahead and do the 4.81 times 10 to the third to get 4,810. Similarly, we'll take the 7.913, move the decimal 5 times to represent multiplying by 100,000, and get 791,300. At this point, we'll go ahead and combine through addition. And get 796,110. Let's go ahead and rewrite this from standard form to scientific notation. We want the decimal between 7 and 9. It's currently after the 0 at the end. To move from decimal to decimal, that would be 5 moves. So our final answer in scientific notation of this problem of addition will be 7.9611 times 10 to the fifth for that move of 5 decimal points in representing our large number. Let's look at subtracting small numbers again. We have 8.32 times 10 to the negative third, 8.32. Negative third means we get a small number, so we'll have 0.00832. And we are going to subtract 5.9 times 10 to the negative fourth. So we get an even smaller number here, 0.00059. And let's go ahead and subtract. And we'll get 0.00773. To get this number into scientific notation, we want the decimal at 7.73. Moving it from where it currently is, that would be 1, 2, 3 moves. So we'll get 7.73 times 10 to the third power, making it a negative to represent this very small number. Our last two examples, one more addition, one more subtraction. Looking at 2.154 times 10 to the fifth power. We will move the decimal to the right 5 times to represent multiplying by 100,000 and get 215,400. Looking at that similarly for 3.5 times 10 to the fourth, we get 35,000. And if we go ahead and do the listed operation, we'll get 250,400. Looking at where the decimal is at the end and where we want it to be between the 2 and the 5, we do need to move that 5 times, that decimal 5 times, and so our leading number, our constant, will be 2.504. Nothing after it needs to be listed because they're just zeros. Times 10 to the 5th to represent the decimal movement, and it is a large number, so the exponent stays positive. Subtracting these two numbers here, 6.03 times 10 to the negative second becomes 0.0603. And if I look at 3.8 times 10 to the negative third, I get 0.0038. And if I subtract these numbers using my calculator or my brain, I'll get 0.0565. And then we're rewriting that so it's in scientific notation. I want the decimal between the 5 and the 6. I need to move that decimal twice to get that number. So my final answer in scientific notation, 5.65 times 10 to the negative second, is we move the decimal twice and we do have a small number.